So what I have here is a shield that I recently developed. It's basically a 915 megahertz ISM band, low bandwidth data transceiver. It's based on the MRF19XA from Microchip. So what I've done here is I've taken this shield and I've stacked it on top of an Arduino variant. And then there's also an Amani F2 FPGA shield in the middle of the stack. And so I have a variation of the shell program, Fruit Shell, called Uba Shell. And what this is, it's a prompt-based shell that not only can you poke at the different I/O lines, you can also access the SPI bus via very basic SPI write and read commands. And so what this does for us is when we have a new board that we're bringing up and it has a register space like the MRF19XA, for example. When you look at the data sheet, there's a series of registers that you have to configure for the unit to operate. And like I said before, if there's no prior work or resources to draw upon, you're going to have to experiment a little bit. So instead of actually writing code and going through the compile cycles and experimentation cycles, you can actually, through a shell program, just peek and poke at the register space and the programming target, and set up the registers as you expect them or feel that they should be set up, and compare the results to your expectations. In terms of the Amani F2 FPGA shield, I've got it set up with the free signal tap embedded logic analyzer. And so what you see on the screen now is a capture of SPI transactions. So to begin with, you can actually do the hardware version of a hello world, where you can send a SPI transaction to the target device. And you can see the results on the screen here. So next up, given that this is a wireless transceiver module, I've gone ahead and taken a RTL-SDR dongle, and I've set up SDR sharp for 915.075 megahertz. And the first series of SPI transactions that I'll perform will be the basic transmitter Bringup. So another advantage of a script-based development with Uba Shell is that you can actually just write a text file with your transaction scripts. So here you see a series of transactions. I'm running to these registers here with the payloads here. So you simply drag and drop the script into Uba Shell. I'm using TerraTerm. You'll see the SPI transactions taking place, and we have the CW tone for the transmit carrier coming up. So now that that's up, I can send a series of other experimental commands. So one thing I was playing with yesterday was actually turning on and off the synthesizer, which should turn off the transmitter. So we'll go ahead and turn that back on. And then we can also set the output power of the transmitter via register 153. And you can select between 0 and 7. These are attenuation settings. So let's go ahead and attenuate with the setting of 3. That should be about 6 dB. Oops. So there's something wrong there. The carrier seems to have shifted to the left. I've got some sidebands, so there's probably some amplitude modulation there. And let's see if I can get it back to where it was. Try a different attenuation. So it does attenuate, but it also shifts the carrier. So I need to do some troubleshooting and some research in the data sheet there and determine why I'm getting this frequency shift. But anyway, that's it in a nutshell. So in review, when we're doing new board Bringup, specifically in an Arduino stack such as this, the Amani F2 FPGA shield can be useful for measuring and monitoring SPI bus transactions, making sure that there's the proper responses back from the chip. And then, of course, there's the UBA shell, which is useful for setting up the various pins on the Arduino and sending SPI transactions via command prompt without actually having to go through the development of a software routine, recompiling when something doesn't work correctly. And then finally, for wireless designs, using SDR sharp with your favorite RTL-SDR dongle. Alright, thank you very much.